So welcome back. In the next slide, I've written down the solution to this, but I will try to do it explicitly here. I think it's worth to do this once. I hope this will work out. All right, so we want to minimize with respect to x a problem. Let's see how it was written. Yeah, I realize that in this slide and the solution slide, I use slightly different notation, but sum k from 1 to big K, or from 1 to n, ak log 2 1 plus gamma k xk, subject to a transpose x plus b is equal to 0, and x is greater than 0. And here, these are vectors, so I'll write them like this. All right, so now the first step we do is we replace this log 2 with a natural logarithm. It will not change the solution in terms of the x, it will just make life a bit easier. And I will give some more interpretation. Instead of b, I will write this like this, is equal to minus b. And this minus b I will call p total, the total power. So we want to have the sum of the x's to be equal to some total power. Okay, now we solve this. The first step is the Lagrangian. The Lagrangian is a function of x. It is a function of lambda, where this lambda corresponds to this equality constraint, and it is a function of a number of additional Lagrange multipliers, one for each of these. So I can write all of these as x1 is greater or equal than 0, x2 is equal to 0, and so forth, till xn is greater or equal than 0. With this, I have a Lagrange multiplier mu1, mu2, till mun. And this is equal to sum k from 1 to n, ak log 1 plus gamma k xk plus lambda x transposed, okay, a transpose x minus p, okay, call this p, minus sum l from 1 to n, xl ul. So this is the definition of the Lagrangian. Let me just double check everything makes sense. Yes. Okay, I see that I switched the lambdas and the mu's corresponding to the previous notation, but anyway. I think it's okay. Anyway, this expression is correct. Then we take the derivatives. The Lagrangian with respect to x. And then we do this with respect to each xl. Let's set it to 0. The Lagrangian with respect to lambda is equal to 0. Each mu l is greater or equal than 0. Each xl is greater or equal than 0. And mu l times xl is equal to 0. Okay, now let's do this one. This just tells that A transpose X is equal to P. Good. And then this one is a bit more tricky. So if I take derivatives with respect to XL, the only term in the summation that remains is when K is equal to L. So I find AL. The logarithm gives me 1 over 1 plus gamma LXL. And then I have here a gamma L that remains. Hope this is okay. Just checking. Then I have the, I just realized there's a mistake. There's a minus sign missing, minus sign missing. So minus sign here, plus, and what remains here is lambda times AL. And what remains for the last time is minus mu L is equal to 0. Okay, so that's the first step. Then the first equation I can solve for mu L, so I can write this as this. Right. And then I can plug this mu L in the last equation. So that tells me that XL times AL times lambda minus gamma L over 1 plus gamma L XL is equal to 0. And now I assume that all of these ALs are positive, just to make life easy, because if it's not, if this A is 0, then I can just remove it, it doesn't matter. Okay, then I would end up with this constraint, so then I have a new system of equations where A transpose X is equal to P, mu L is greater or equal than 0, XL is greater or equal than 0, XL lambda minus gamma L1 plus gamma L XL is equal to 0. And now the mu L I can replace with the expression here. So I can say that lambda minus gamma L over 1 plus gamma L XL should be greater or equal than 0. Good, already it's simplified a little bit. Then can we further simplify this? Let's see. From these expressions, I find that A transpose X is equal to P. Lambda is greater or equal than gamma L over 1 plus gamma L XL. Okay, nothing changed. XL greater or equal than 0. And then again the last expression XL, lambda minus gamma L over 1 plus XL gamma L is equal to 0. Good. Okay, done. Now, this last expression breaks up into two cases, right? XL is equal to 0, or lambda minus gamma L over 1 plus XL gamma L is equal to 0. These are the two cases. Now, this is easy because we've already found the XL, but if lambda minus gamma L is equal to, so if this last expression holds, then it implies that lambda is equal to gamma L over 1 plus XL gamma L. And then this we can solve for XL. Let's see how this works. 1 plus XL gamma L is gamma L over lambda, so XL is gamma L over lambda minus 1, and then 1 over gamma L, 1. Now we have this expression. Oh, this is tough.